Hello, this is Mr. Wilford, and I just wanted to go through Chapter 8, Section 4 with you, angles of elevation and angles of depression. And this ties into our solving right triangles that we talked about in the last section. Hopefully this kind of makes sense. We have a couple of terms here, an angle of elevation and an angle of depression. And if I go up here a little bit, you can see in this nice picture here what we're talking about. We have an angle of elevation, which, if you can imagine looking straight ahead and then looking up at something, that would be an angle of elevation. And you can see there that's angle 1. And then when you are looking straight ahead, and if you look down at something, that would be the angle of depression. So it's all kind of relative to where you're at. And so what we have here are some different problems that involve the angle of elevation and the angle of depression. So in this first example, it says classify each angle as an angle of elevation or angle of depression. So it's just making sure that you understand exactly what we're looking at here. Angle 3, if you notice where angle 3 is right here, this would be an angle of depression because as you look straight ahead, you're actually going down and measuring the angle below that horizontal line. So that would be the angle of depression. Angle 4, if you look at angle 4 here, again, if you go to the horizontal line and you go up, that creates angle 4, so that would be the angle of elevation. Really, you just want to make sure that you understand the difference between elevation and depression. And here's an example of using that where we have an angle of elevation of 41 degrees. So we're looking up at something at point P, 41 degrees, and the pilot here in this example reports that the plane's altitude is 4,000 feet. And so what we've created here is a nice right triangle. And we want to be able to solve the right triangle. We're given the angle and one of the sides here. Whenever you're given an angle and both legs of the triangle, the best way to go is to use tangent, which we have here. And we're using tangent, which is 4,000 opposite over adjacent, which is x. And then doing some cross multiplication or solving for x using our calculator, we should get 4,601 feet. So that's a good example there. And again, these are going to be pretty much kind of application problems. Here's another one where we have a 90-foot tower sees a fire. The angle of depression to the fire is 7 degrees. So that is our angle there. We want to know the horizontal distance between the tower and the fire. So what we're trying to find here is this length here. Again, it's good if we can use tangent. Again, that's kind of an easy trig function to use. Now the thing that's going on here, if you look at this triangle, if this angle in here is 7 degrees, then by alternate interior angle theorem, if you have two parallel lines and you have a transversal going through, these two angles are going to be the same. So if this is 7 degrees, then right here is 7 degrees as well. And so that's how we end up with 90 divided by x. Again, solve for x, and that will give you the distance away. Again, there's all sorts of good examples here. Here's another aviation example, and that just involves a few different triangles. If you read through that, hopefully that won't be too bad for you. Again, if you have any questions with any of this, please let me know. Thanks.